So hello everyone, my name is Julia Körner and I'm an assistant adjunct professor at UCLA. I'm part of the faculty since 2012 and I teach in the graduate program at UCLA. Today we're going to show you an insight into our research which we have conducted at AUD, at the Architecture and Urban Design Department, which was focused on innovative new technology with 3D printing with clay in our robotics lab at IDEAS.
So I'm Tyson Phillips. I am the manager of the Robotics and Technology Laboratory at IDEAS in the post-professional architecture program at UCLA. And I, for this research, was largely responsible for establishing the workflow that went from the parametric design software all the way to the physical robots in the laboratory.
Hi, I'm Shendi Jan, class of 2018. I major in Master of Architecture 1 program. So during our independent research, Fluidity and Plasticity in robotic 3D printing with porcelain, I was mainly focused on the extrusion mechanism and the material research.
Hi, my name is Zhou Fan Chen. I graduated from MRCOM program year 2018. So in this research, we utilize the programmable capacity of an industrial robot arm to achieve a precise level of control to the fabrication process, which enlarges the domain of the freedom of the form and texture that porcelain can achieve. So my role in this research is mainly focusing on development of the robot path optimization in digital environment and developing a way to use Arduino to control our extruding system.
Hi, I'm Gabe Strezbeck. I'm an MArch-1, current MArch-1 student in the class of 2021. So I started at UCLA the year after the research was completed. My role has thus been primarily focused on contributions to the research paper. So right now I'm working with Julia on furthering the earlier research and looking at future applications. One thing that was really cool about this experience is it's an opportunity for me, an incoming student, to work on a project that's already been in motion. One that is really quite fascinating. I think clay is a really, it's kind of an untapped medium in this way. It's one of the oldest construction materials used in history. However, using digital tools to fabricate it is kind of a newer idea. And so one thing that's really interesting about clay is it embeds the construction method in its design. So as you can see with the pictures on the left, that's more of a historic take on clay. And you can see little rivets where the slats were to hold the clay in place. However, on the right, you can see it's more of an additive process. There's more of a layering technique, and you can kind of read that in a different way.
Our research has 3 different parts, and we're trying to utilize the material research to determine the most appropriate clay type, and then use that technique and the base to develop a highly customized extruding system by referencing some technical research. And finally, the goal is to prototype a complex clay form incorporating fluidity and plasticity to demonstrate the potential of expanding the materiality of the porcelain clay through the process of robotic fabrication and optimization. So this diagram showing the relationship between the whole system and our robotic arm. Our extrusion system is mounted on our robotic arm and is controlled by our electronic control unit. We have 3 different versions as the research went on, from the V2 extrusion system all the way to the V3. So the whole system is proven to given the clay to be printed from the small scale to a large scale, and also the component that we use that are more industrialized, so all the system can be more reliable and secure. And also it's very easy to clean and maintain. So this is our early prints. Because the clay has a wide variety of on the market, is a huge wide variety of the clay. So it's very critical for us to test first as many as possible to better understand which might be the best solution for us for the 3D printing on the robot.
So since my main role in this research is focusing on the development of robotic parts and optimization, so during this process, we went through several different prototyping process to test the mechanism of the extruding system and the materiality of the porcelain. Here it's a video showing the fabrication process when we moved from small robot arm to the bigger robot arm and the process of the final fabrication. The final prototype is composed by 3 identical parts on a triangular shape. Each is formed through a weaving path that has many distinct corners pointing outward, just as you see from the video. So they are also being connected at the center to provide the basis of the self-supporting structure. So the ultimate goal was to fabricate a complex clay form incorporating both fluidity and plasticity in order to develop a new aesthetic and functional characteristics such as reinforced structure through internal buttressing and layer overlap, visualization of the material, and the control of the aesthetic expression with the robotic fabrication. This image is showing the final result. It's a close-up image of the texture and the patterns on our final products. From left to right, you can see the dripping patterns effect and also some weaving patterns being showed on our final product. This one is a visualization of the fabrication process and the actual fabrication side by side. After we finished the research, we participated in the exhibition in Rumble 2018 at ITS campus.
Well, I think personally, I was really excited about cross-bridging between the MArch-1 and MSAUD program, and to kind of really develop a research which is not only confined to the curriculum of like one term, but essentially to establish a research over several independent studies where we were able to develop our findings and knowledge further, but also where you, Jofan and Shundi, were able to share your experiences with Gabriel, and therefore there was an exchange between different years of students. And I think that was really exciting for me as an instructor to experience that knowledge exchange and to work with you on finalizing this research in an academic conference paper this spring, which we are now able, to publish and share and hopefully show in some great exhibitions in the future. Thanks for joining us today, and looking forward to see what you all do next.